A smooth piece of ice is projected upwards in this direction through an inclined surface. Now its position x from this point at any time t is given by this equation. So we have to find the acceleration and velocity for the ice block, and also we need to draw the graph. So let's first do that. So the velocity will be dx over dt, which will be 6 minus 2t, and acceleration will be dv over dt, or dx square over dt square. So this will be minus 2. So this is a fixed acceleration downwards. So if this is in foot, this is, of course, this is in feet, this is feet per second, and this will be feet per second square. It's a downward acceleration. Now we need to draw the graph of displacement and velocity. So let's rewrite the displacement. This is a parabola, so we need to complete the square actually. So let's do that. Let's add 9 there and 9 there. So this one becomes t square minus 6t plus 9, which is minus t square minus 2 into 3 into t plus 3 square, like that. So this is t minus 3 whole square, and this is x minus 9. So the graph will be like that, the displacement. This is t there, this is x there. So the vertex will be 3 and 9. 3 and 9. So 3 in this direction and then 9 here. So that's there, and this is a parabola. Since there's a negative sign there, it will be downwards. So it will go like that. So this is 9 here feet, and this is 3 second there. So that's the displacement. And velocity is simpler, it's a straight line, 6 minus 2t. So 6, x is 6 minus 2t. So when t is 0, x is equal to 6 there, so that's 6, and when x is equal to 0, t is 3. So it's negative slope straight line, so something like that. So that's 3 here. So of course what it shows is, this is velocity, sorry, it's velocity, sorry. So yeah, so that's 6 feet per second there, and then this one is 3 second. So up to 3 second the velocity is in one direction, but it is decreasing. So it's actually going upwards because of the because of how it is projected upwards. And then at this point it reaches maximum height, or maximum displacement, and then this one comes down, it comes down again, and here it reaches the bottom, which is this point there, and the velocity is increasing downwards in this direction. Initially velocity was still decreasing, but it was in the other direction. So that was upward direction velocity, which is up to 3 second, and then from after 3 second afterwards it's going downwards, and it is increasing the velocity. So we try to find, when t is equal to 2, which direction the ice block is moving and which direction it is accelerating. So when we say it's which direction it's moving, we can see v is equal to 6 minus 2 into 2, so that is 4 feet per second, but it's still going upwards, as we can see. At t is equal to 2 is somewhere there, so the displacement, it's still going upwards, and the velocity is decreasing, but it is still going upwards there. And at t is equal to 4, what will happen? The velocity is here, which is, and this one is coming down there. So at this point this is coming down. Now at this point, for both points the acceleration is negative. That means the acceleration is actually downward. So when from 0 to t is from 0 to 3 second, this one is going upwards, the ice block, but it is decelerating, so we can say the acceleration is downwards, while 3 onwards it is coming down with an acceleration, so there is a downward acceleration from 3 onwards. So yeah, that's it. And then we need to find is the ice block stationary at any point. So again, v is equal to 6 minus 2t. So when it is stationary, the velocity will be 0. So we can say at t is equal to 3 seconds, this one is stationary. If we look back in the graphs, this is where the velocity is 0. And of course, sorry, I wanted to use another color. So this is where the velocity is 0, and this is the point when it is going upwards, reached the maximum height or displacement rather. So this is where after that it is coming down. So this is where the velocity becomes stationary and then it comes back immediately. So the acceleration is downwards all the time, because if we draw the acceleration curve, it will be a fixed line minus 2 feet per second square.